The question is, a player throws a ball with velocity 16 meter per second from a point A as shown in below figure. Determine the highest point B where the ball will strike the wall. See, we could have assumed that this ball is going to strike the same floor. Okay, if the wall is absent, but now here in the presence of this wall, instead of striking the ground, it is going to strike the wall. It is going to strike the vertical wall. So let us assume this as the path of this ball. So here it is striking the vertical wall at a height of at some height. Okay, we don't know what is the height of that point B where the ball is going to hit. Let us assume that height as h from the floor. Now next is here the horizontal distance between this point A and point B is given. So horizontal distance we denote that with x. Okay, if the points are on the same level, then we denote that with r, that is horizontal range. If the points are at different levels, their horizontal distance we denote as x. Okay, so whenever there is a x, we have to find the y also to use the equation of trajectory. And what is that y? Y is the difference in level of point of projection and the point of landing or the target. So here point of projection is this A, and point the target is this point B, and the vertical distance between these 2 points we call as a y. So what is this y? Say from here to here it is h. So out of this h I have to deduct 1.5. So it is h minus 1.5. So y is also known to us. I am writing the equation of trajectory here as x and y values are known. Values are known. I have to use equation of trajectory, that is y is equal to x tan alpha minus gx square upon 2u square 1 plus tan square alpha. Now if we look into this equation number 1, let's check what are the values known to us. Yes, y value is known to us, that is h minus 1.5, and x is known to us, that is 18 meter. And what is this alpha? So alpha is unknown. Then next coming to here, x is known, uv is known, and alpha is unknown here. Again it's a problem similar to the uh, previous one. In the previous numerical also, all the values were known except that alpha. So how to find that one? Now again if we look into this figure, there is one hint is given there. So that hint is the maximum height which this ball can travel is from here to here. So this h max equal to, it is 6 minus 1.5, and it is 4.5 meter. So use that h max to find the alpha. So that can be found, h max is equal to 4.5 meter, and the equation of H max is u square sin square alpha upon 2g it is. So it is 4.5 is equal to, what is that u here? U is 16, so it is 16 square sin square alpha upon 2 multiply with 9.81. So on solving this one, we get alpha as 35.963 degree. So now for this one, the values are, all the values are known to us. Y is h minus 1.5, x is 18 meter, u is 16 meter per second, and alpha is 35 point, and alpha is 35.96 degree. Now only you have calculated this one. So substituting all these values in this equation, so it becomes h minus 1.5 is equal to 18 tan 35.96 minus 9.81 multiply with 18 square, 2 into 16 square, 1 plus tan square, 35.96. On solving this equation, it is h minus 1.5 is equal to 3.584 and h is equal to 5.0841 meter. So this is the height from the floor where the ball is gonna hit the vertical wall.